won it, and we know you won it. Thank you for being here, Nelson.
Thank you. Thank you very much. Okay, so Nelson Vides here. My talk is called Building Blocks and How to Use them. MongooseIM case study. Let's get started. First, me. Some people know me, but not all. So, who am I? This is Nelson Vides. I was born in Venezuela, grew up around here in Spain. But a long time ago, I moved to Poland on a bike. That's the logo that I have everywhere. If you find me on Twitter, on GitHub, LinkedIn, everything in the universe, that's my picture, so you don't get confused. I'm an Erlang consultant and core MongooseIM developer. I consider programming a free hobby time in a sense that it's hard for me to stop on like Sunday morning. You know, you're on a hangover. I woke up in the morning and I just want to code. It's addictive. I like it. But I have a special unhealthy obsession with performance. Before being an Erlang developer, I was a C developer. And I was a C developer because, you know, the hardware, things get fast, this is cool. But how did I move to Erlang? This is how I started. This is Robert Virding, so most of you may know him. This is one of the creators of the Erlang language. Around 3 years ago, I was you know, a fanboy kid just trying to find my way, and I went to a meetup, Erlang meetup there in Krakow, and there was Robert Virding. I was shocked to death. I never expected that, and immediately ran to him just to kill him with questions. I wanted to know everything in the universe. And one thing that I learned at night, apart from, you know, how the garbage collection works and the log contention and all the problems that I have in C and all the other technical stuff, was how cool the community is. There is this legend that could be, I don't know, meeting some CEO or something, and he took the time, and I'm talking about like hours, really, it was not 1 or 2 questions, like, it was hours. He took the time to explain every single question I had to just some random kid he just met in some random city. It was lovely. Shortly after that, the HR manager in Krakow was telling to Robert, come with us. Oh, you're with Robert, wanna come with us? And that's how I started in Erlang Solutions. But this is how I started programming and stuff, but how I really started, I want to take 1 second of a thank you. How I really started is thanks to my mother. I had many ideas in life, and many people taught me many things. Robert told me about garbage collection and all that stuff, but hard work was not my area. That was my mother. Thank you. What do I do? MongooseIM. It's a customizable messaging server. In history, in archaeology, like there was this old project at the beginning of the internet. There was this protocol, the XMPP, and then there was IJRD, which is an implementation for that protocol in Erlang. There are forks for it. Most of you, especially Spanish people, know 1 fork of IJRD. What's up? It's Erlang. So we share some archaeological background. There is this other fork, MongooseIM, that we build it to be specially customizable. The usual use case is, we work as a consultancy. People, for whatever business logic, they need some kind of messaging system. And so they call us. We have this open source project that is ready to get all your millions of clients that you're dreaming your business to have. And it's especially customizable, whatever special functionality that you want, we will build it for you. The server is robust, scalable, and efficient. These are just the archetypical Erlang buzzwords. Obviously, it's the Erlang, it's the BEAM. You have to like intentionally do it wrong, so it's not scalable. How is it scalable? This is some load test that we ran about 2 years ago, so there might have been some change because we have done lots of performance improvements. Usually, I'm obsessed with performance. When I was programming in C, I had this idea. When I was a kid, and I had like so many illusions. I had this idea that you put your program in a computer that is twice as powerful, and your program gets twice as fast. You double the throughput. If you double the speed of the processor, the number of cores, the RAM, like you should get some also doubling of the effect of doubling some hardware. It's not true. Then you get log contention. Then you get all these terrible problems. So the dream is like how linear it is. You double the power, you get double the throughput, the performance. And so we ran this load test in AWS machines, and we were testing the number of connections that we can run for one-to-one connections, sending a message to each other I think it was every minute or every 50 seconds or something like that. And at the moment when we run out of AWS credits, at some point this gets expensive, was with the C59, which is 128 gigas of RAM, and I don't have the notes, it was all written here, but 128 gigas of RAM, and I think it was 64 cores, if I remember correctly. And at that point, we were at 2.5 million connections with a time to delivery below 100 milliseconds. So CPU was already like the higher 95s. There was still room for a bit more, but there was no sign of crash or getting into trouble. But these are high numbers. It's like, the speed of your car, it says that your car can go at 200 kilometers, but you never go at 200 kilometers. The highway is not that good, it's not legal, whatever. So, not theory, but in practice. Here we have an example of this university. Some statistics from 2018. I wasn't able to find the newer ones. You have around 16,800 students and this many professors. Let's say 20,000, like rounding on the higher numbers. On this C5 large, which is 2 vCores and 4 gigas of RAM, you can get at the message interval, this is a message every those many seconds, you get those many connections before maxing out the machine. If every student, professor, and employee of this university decides to connect and write a message every 15 seconds all the time, that's quite a freaking... Usually you write in bars, you write like 3 messages in 2 seconds and then you wait. But an approximation, every 15 seconds, you still get to 68,000 people chatting, so 2 cores, 4 gigas of RAM. My grandma has a phone with more hardware than that. How does it work? So we have the internals, persistent terms. This is what has changed in the last 2 years, so I will repeat those load tests. There is a typical architecture of C2S processes. Everything runs with hooks and handlers, and of course, Erlang, big thing, the message passing. How? So the first thing, the configuration. You can, the clients connect through a virtual host, a server, a domain, like through DNS. And you can virtualize in a single machine. You can serve many of those domains, and they can have the same configuration or different ones. And this is something that we reworked a lot. Back in the days, the configuration was Erlang terms that was translated by some complicated logic scattered everywhere into the configuration, and then the functionality will interpret and decide what to do. This configuration was stored in arbitrary Erlang terms, some of them in Nisha, some other in one global ETS tables, other in like a custom ETS table for this module. The Nisha one was shared in the cluster, but the ETS table was not. It was not really consistent. So we reworked this massively since 3.7.1, which was just before pandemic. So productivity skyrocketed with remote work. We first reworked the front end. Now you don't write this configuration in these horrible, huge Erlang terms with nested tuples of hell. Now it's a TOML file. Very readable. You don't need to know Erlang, and even if you know Erlang, you don't need to suffer this configuration. But in the backend, everything was just a horrendous transformation still. Recently, just 3 days ago, Wednesday, 2 days, 3 days ago, we released 5.1 where all this internal representation is reworked to one huge map that has keys and values, just representing the TOML tree, and it's stored in one persistent term. Micro benchmarks showed amazing performance improvement. We still have to run like the real load test with like real clients and so on. It's not the same micro benchmark. I'm not here to talk about load testing, but this is one of the things that I find so elegant about this tree in the configuration. That if you have, for example, the domain and then the module, and then there is a subsystem of the module, and then the timeout, and you want to see the timeout, you literally write the path in this tree, and in, how many lines is here? 5 lines of code, you can traverse this tree, find the configuration that you're looking for, and tell to the module how many seconds is this timeout that you configure. Things like Vides before used to be like hundreds of lines of code in different modules. It's messy. The architecture. This is the typical Erlang architecture. You have a supervisor. It's still called a Java supervisor because of historical reasons. On startup spawns a listener with some socket options. You put it in the configuration, and it binds this port. it gives this port to a bunch of workers that loop on an accept loop. Every time there is an accept, this is the TCP protocol, you might be familiar with it. Every time one is accepted, the C2S supervisor says start achievement, and you have a C2S client. And this C2S client, client to server, represents the connection of this client. This is the Erlang way of achieving infinite scalability. You connect more clients or more processes, concurrency for free. And these processes, if this moves, this process starts the FSM machine. There is some steps for initializing the stream, authentication, and so on. Once you have your session established, the state session established, I'm missing my notes. You get to these two important things. The UseSM packet, some hook is called Mongoose hooks, UseSM packet. Is it readable? More or less. And then the route. Find the person you need to send it to. On the other side, every supervisor using worker pool is starting a diverse myriad of pools. Some of them are the RDBMS for storing messages. There is an HTTP pool that could also be, there is the authentication pool that could also be RDBMS. Often is an HTTP service asking the user's microservice, does this user exist, and so on. And then there is all this functionality for MAN. This is a message archive management. So if you want to store your messages server side, there is inbox. They may give requests to the RDBMS. These pools have hundreds of workers. Again, concurrency for free. An important point here, the UseSM packet. What is this Mongoose hooked UseSM packet? Here is where I'm afraid that this might not be readable. Maybe. Okay, these hooks. You have a hook is an event. There is an event UseSM packet, and then there is subscribers that you want to tell them, do your thing. How do you register these things? There is a Gen server that handles an ETS table that is protected, so only he writes, but reads are public. He builds this record, search that this was not inserted before. If it was not, then it inserts this new subscriber, this new handler, according to a priority. And then to run it, you look up the ETS table, you get your list of subscribers, run them one by one. This might be familiar to some people. This is the implementation of Telemetry, which is quite a popular library. This talk is about open source. Of course, I work in MongooseIM, so I talk about MongooseIM all over the place, but MongooseIM is an open source project where we collaborate with other open source projects, and there is plenty of knowledge sharing and flowing all over the web. Telemetry, one of the main guys that created Telemetry, Arek Hill, you might have seen his name sometime, he was working in Erlang Solutions. He left the company a few months after I joined, and I remember this conversation when I entered the company. He was talking about telemetry all the time. It was a new thing, and I was like, what's that? Tell me. And improvising, he drew something like this on the whiteboard. And so you have an event and you want to do stuff after that event, and there is the typical OTP behavior, the again event, that if the handler fails, it's removed. Everything is run on one process, so there is an event and you tell one process, here there is an event, you process, execute all the subscribers. That doesn't scale. If this event happened millions of times, there's one process and it's going to get all these events and execute all the handlers. And it doesn't have this reduce and order functionality. What is this? This is something that we wanted in MongooseIM, and that specifically Arek said that this was not a good idea. It's too hard to keep it clean. It's a good use case because everything is internal instead of MongooseIM. We know all the places we're going to use this. But for a generic library, it easily introduces how do you call it? Dependencies between handlers. The first thing is that there is an order, and when you register the handler, you register it in a given order, and you want this handler to be executed first one, and this one to be the last, or in a certain order. And that is important. For example, you have the archive assigns an ID, and then you have carbons. You have two devices, you send a message in one, you want your message to be on the other device immediately. But that other device may get this message with the ID that the archive assigned. So you put the carbons after the archive, and then you use what is the reduce. There is an accumulator that is passed through all of them. So the following handlers can get information from the previous one, and then you can consult what was the ID, okay, and I append it, and then I send it. This introduces some coupling between the handlers. So as I said, not a good fit for an open source library, but a perfect lesson for Eric to create the open source library that now Phoenix uses. Oh, and everything is run in the context of the process that started the event. So then it scales. If you have 1 million clients and they all trigger the users and packet event, they all individually execute these handlers. Then, these are some examples of things that can happen here. You can have matrix handler, push notifications, the carbon copies that I mentioned, of course the archive. Insert here your customizable handler for this event. That's what we do. And how does it work? After the user handler, you have the router. Router will find is this a federated server, is it some local delivery? Let's suppose it's a local delivery. Checks privacy, maybe somebody blocked me, so I don't want to deliver this message. If it's a group chat, then it does the group chat, give me the users. Another event, there is a message on a group chat. And after that, then route this to all the users. Up again, routing, local delivery, EJR DSM, session manager, get the beads and do the usual way, bead, exclamation mark, route this thing. Route accumulator, and then on the handle info, you get this route accumulator, another event, user receive packet, metrics, things like that. Send text, put this thing on the TCP socket. What am I doing with time? I hope not to steal too much time from your coffee break. The river config. This is only the dependencies, of course. I mean, the river config is enormous. But just the dependencies, unreadable, don't worry, I will zoom. The beginning, just stateless parsers. There is base16, EXML, GFI, people know these ones. These ones that are on color are some of the things that we took outside of MongooseIM. A very simple thing is a base16 algorithm, which was not included in the standard library into OTP. There is this package in hex called base16 that has a bazillion of downloads. It's apparently super popular. It was created in Netherlands Solutions ages ago. Then there was the improvement for the performance using the hype, but then hype died because now we have a JIT that does this job better and many other things. So I was curious a bit how to keep this algorithm performant, and I improved this base16 library. And then I saw that they were adding this thing into OTP, and I was like, hey, I have this algorithm that I have profiled the JIT compiled code and just manually check because I'm obsessed with performance. And I worked on C, so I like reading assembly. So there it goes to OTP. Base16 is something that we use to escape encrypted data, to escape things from the database. It's a common use case that you will use. And now it's on OTP since 24, if I remember correctly, so it's not up there on 23, but if you're running on the latest, you can use it. If not, it's exactly the same code on a hex dependency. Another thing, EXML. This is the moment where we parted, MongooseIM parted from EJRD. 11 years ago, if I remember correctly, one more, one less. One contribution that MongooseIM made was to use binaries instead of lists for the strings. The whole protocol is XML based, but you need to parse the XML and then you manage strings that you throw on the database, on the TCP port, etc. This was done with the old way linked lists, was not scaling, and then in the MongooseIM team it was written this XML parser, was based on a different C code. Everything is binaries, and it was based on a different backend. Then it was improved, then it was transitioned. Right now it's based on Rapid XML. And this is the moment where we parted from EJRD for technical decisions. They wanted to take a different direction for the project, so we made a fork. Now it's called MongooseIM. This was 11 years ago, so everything is different by now. Though. This implementation, I was checking for preparing this presentation, how many XML parsers are there in hex? And for Erlang, I found 2, the one that EJRD uses now and the one that we use. And for Elixir, there was another one. And then there is the OTP standard one that is very slow and generates atoms, so be mega careful with that one. Especially considering that clients are sending the XML, so they will kill your machine. Our implementation is especially fast, like 20 times faster than the EJRD one and so on, because we cheat a little bit. This implementation is not, it's an if, so it's C code. It is not, how do you call it? it's not scheduling, it's not micro-scheduling the steps. It runs as one single thing. So if you give a really big input, it will parse the whole thing, and that may run for too long, more than advisable for NIF on the BEAM. It is our use case. You are not supposed to send messages of 3 megas long, because like, who writes that many characters? And also, if you're running this, you can run on memory pools. This is what is described here. By default, there is this 10 megas, so you can parse this stuff. So we cheat a little bit, but because it's our use case, you wouldn't use this to parse arbitrarily big documents. This is for messaging. Also, open source, nothing related to MongooseIM here. There is just the parsing, the XML data structure. Use it anywhere you need an XML data structure. Another thing, the XMPP JIT parser. This is a bit more of an XMPP thing, and XMPP servers there is HRD and MongooseIM. But it's code that you can take out. Back in the days it was nested inside of MongooseIM. Code that you can take it out is self-tested. You don't need to test the whole XMPP protocol. You need to only test that the identifiers, something similar than emails, more or less. The identifications can parse correctly, build correctly. You can put it on a different CI, different repo up there for usage. In observability, there is of course the influence that we have on telemetry, and that I'm very proud of. And there is syslogger. If any of you is trying to deploy the old way on a Linux and you want the syslogger with all these identifiers and so on, this is a library that was written, I think, as part of a hackathon or some hobby time by Lucas Larsson, also Elan Solutions employee from the Stockholm office, the guy that the JIT compiler, so big kudos. He made this syslogger library, but it was a bit of a hobby thing. It was like not complete, some bugs, and then I wanted something like this for MongooseIM, so I fixed the two problems, and there it is. It's ready on Hex, load tested. It has two branches, master, which is the one that Lucas made this build with auto tools, and I just made a new branch that is called main that is built with Rebar. It's the same code, but just a different building tool. Description for this. Again, I don't have the notes, so I didn't know that I forgot that this was the next slide. Some stateless libraries. There is two important ones here. FastTLS, this is an optimization from HRD. OTP TLS, for all the advantages that it has for scalability and deployments and so on, is of course way slower than an if one. It has still been improved a lot. And there is the fast CRAN. Where this thing came from? MongooseIM 3.7, so the last one just before the pandemic. We were still starting to get active here. We wanted to build a bit more security, so support TLS 1.3, which 2 years ago was quite a thing. OTP was still not on 25, so it was still experimental. We implemented Scrum algorithms. The XMPP RFC requires Scrum, SHA, sorry I pronounced SHA, 1, but it's quite a low one, so give support to all the others, and also channel binding, which allows you to bind data from your authentication layer to your network to your channel, to the TLS channel, which the protocol goes on top of TLS, where you can bind the data and detect if there is a middleman in your TLS layer. For this channel binding, we made a contribution to FastTLS, and for all the Scrum stuff, I took already like 45 minutes of a lot of people's time to explain this, so I have a slot here for one talk, not for two. I already explained Scrum some time ago. And this is the FastTLS for the library from HRD. They were not using Dialyzer, Brujo. It was not integrated. Fortunately, now I made a pull request, now they use Dialyzer. Fortunately, it's a small project, like 3 modules, so it was easy. You put Dialyzer. There is these 20 errors, not so many, absolutely unreadable, but only 20, so you take your time, you fix it. There is the plus for this channel binding, the loading mechanism, and plenty of places where back in the day it was doing something like integer to list to binary, something like that, which was always contributions. Some other dependencies that we have in MongooseIM. There is the one and only great worker pool and the segmented cache that I did recently, and again I don't have the notes, so I don't remember which one is the first slide. The segmented cache. Okay. So, for example, In the group chat case, you send a message to a group chat, and now you need to check the people that are in this group chat that are going to receive this message. So you usually check that on the database, depends on your deployment configuration, it can be on React or like the sky is the limit. Usually you just use some Postgres, it has the affiliation list for this group chat, you fetch it, deliver to all of them. Now imagine that you have this super big server with hundreds of thousands of people connected, and there is this group chat with like 500 people. It's not a super big group chat. Okay, it's a big group chat. Depends on, I don't know, ask your family. There's always this family group chat. And imagine that all of them send a message at the same time. Why fetching the database for the affiliations 500 times when you can just fetch one and everyone else uses this? So there is a cache library. We needed it, we implemented. Cache libraries that I found on Hex often were doing the Gen server way. So all the inserts were through a Gen server, and then the reads were public. It's an ETS table that is protected. Everyone can read, but only one can write. So when you want to put something, you send him a message to put it. The problem is, what if suddenly a lot of people want to put a lot of stuff? And the next problem is the case of 500 people sending a message at the same time. The first one checks the cache, it's not there. Okay, Gen server, put it on the cache. The next one hasn't found it yet, so he asked the Gen server to put it again. The next one hasn't found it yet, and so on and so forth. And now this Gen server has 500 requests to put exactly the same record. So I wanted an ETS table where everyone can write, but then as a cache, it needs some cleanup mechanism. And the whole state keeping with timestamps and so on was a little bit expensive. I wanted mostly to survive burst. There's Christmas, everyone connects and sends a message at the same time. So you need to survive this explosion. So everyone puts on the database, on the ETS table, and the ETS tables are simply very lazily rotated. Every configurable, 1 hour, 2 hours, depends on the use case. You have 3 ETS tables, everyone inserts in the front, and every timeout you put this ETS table at the second, the last one you remove all the records and put it as first. And this continues moving, so eventually you will drop all the data in a very lazy way. No micromanagement of every single record. It's an approximation in hours. Mostly everything on bars, everything will be on the first table. Sometime later, I got a pull request. I was very excited for this. This is the cool things about the open source world. At some point, you're not the only one making pull requests to your project, but suddenly you get stuff. I was not an expert on property-based testing, which I regret, and everyone should. So I got a pull request where I learned a lot about it. You know, how to test with parallel workers, how to test with a state. Thank you, Pablo. The advantages of open source. Worker pool. So I'm obsessed with performance and profiling, MongooseIM, and there is this case where you need to write to your worker, you need to tell to the database, put this. So first you need to choose a worker, and then profiling, I saw that usually the database operation is way, way fatter in comparison to just choosing your worker, but still, it was there. It was in the profile, I could see it. And in my head, this is not what I want to do. I want to tell the database to do its job. Everything else, I shouldn't see it on the profiles coming from C. I don't know, wishful thinking. But I tried to improve it. Made a bunch of pull requests. One of them was eventually to put all this data for the workers on a record on a persistent term. And suddenly, on a very lazy request, where you just tell your workers return OK, so it's not that the worker is doing any fat work. Before that, here we have finding the worker the whole way through ETS tables and generating the names and so on was taking around 15% of the time. Considering that the actual work was just return OK, so like this in proportion to a database operation will probably be nothing. But for a nothing operation, 15%. Persistent terms now is 0.22. I had to put this. When Bluehorn released this library, he released this, he put on Twitter this with thank you to the people, the awesome worker pool, and my Twitter feed just below threw this message from Elon Musk. Friends and pools are great. Thank you, Twitter. HTTP tools. I don't have much to say about this one. It's yet another one HTTP client library that you can use. Generally very good for testing. It's super easy to use. So what you want, it's not the library that I would use on a production server. When I have a server and I want to test it, it's a fantastic library. Not much to say. Let's go to the outgoing pools. In MongooseIM, you can use as your backend all the usual SQL ones, so Postgres, MS SQL, MySQL. And there was some test with MongoDB. Of course, we have React, because why not? You can also use, what was it, Cassandra. There is a Redis for caching. Everything is somehow compatible. And all those databases, they use their own protocols, and for all of them there are dependencies, there are plugins that allow you to use them. As you can see here, there is just one that is kind of ours. All the others are the work of other people, for which we are very thankful. But this EODBC, ODBC, Microsoft protocol, you can use it with Postgres or other stuff, but you would usually use it with Microsoft SQL Server. You might know this stuff. There is ODBC support into OTP, but it has plenty of limitations. There is bugs open. There is complaints. There has been cases of big companies that want to use ODBC and the OTP one doesn't work, but there is no movement into fixing it. So in the MongooseIM team, we just took this code outside of OTP, made it into a proper rebar packet that you can just install through Hex and fix the problems. There is a dead pull request somewhere in OTP that unfortunately sees no movement, but if you need ODBC, we broke the support for Postgres, but if you're going to use Postgres, you probably just use the Postgres one. But at least for Microsoft SQL, here it is, fixes the problems that you could face. And some internal monitoring and debugging tools. On a live server, this is installed on the live server, so you can go to production and see things with Recon or the Observer CLI. And there is this one package that it's not installed on the live server. It's not installed on the live server, but I use it a lot on development or on debugging. Suddenly there is a bug, I can reproduce it, but hell, this is so complicated. There is this tool called Gerland Doctor, also developed in our team, where you can enable tracing for everything in your system or only for a few specific modules and so on, and it dumps all that tracing to ETS tables. So the regular tracing sends a message to your process, so if you are tracing everything, the mailbox of that process explodes immediately. This one scales a little bit, and we don't do it in production obviously, because it consumes memory, so you will get killed. But it's very good for debugging because then it stores on the database and on the ETS table everything, absolutely everything. Every single function that you call with every single argument, with the bit names, you can even ask if there is functionality to repeat this call. Because it stored the MFA, the input, you can just say execute it again and manually see what happens. And then you can use filters with this ETS font2ms. You can write your match specification and it will return your data in any possible way you could imagine, and it has been my favorite debugging tool. So much bugs that I have fun with this. And this is it. This is all the stuff that we do in open source. These are all the contributions, and between the contributions you saw all the projects that we use that we haven't contributed to, but we're very thankful that someone else contributed to open source. Hopefully you will get free pull requests. Thank you very much.
Thank you. I have a question regarding the performance. In the past, before the persistent term, one trick was to use the process dictionary. I know it's a bit of a crime to do that. if you put your performance in the balance. So I was wondering what if you have tried using the process dictionary on the persistent term, and was there any difference? Was it better? Was it worse? I was wondering in a huge case like Mongoose.
Yeah, the process dictionary is not something that we would put on the client-to-server process, because the client-to-server one, you can have millions of them. With a process dictionary, they take more memory per process, and if you spawn 2 million of them, there is this half a kilobyte, but you know, when you multiply. The other problem with the process dictionary is that it's a linear search. So if you put in the process dictionary 500 items, then you get this bigger O of n if your item is the last one. Why would you put 500 items on your process dictionary? You usually maybe put 2 or 3, so it's fine. We have tried this trick, not in the C2S process, but maybe on the worker process that interact with the database, because I know that there is so many of them, so if each one of them take this amount of memory, you know, it's not going to grow that much. But yeah, but the thing with the performance, with the persistent term and its configuration, they all are going to read the same data. And you are not going to change it on through the life of the server. So performance-wise, it was even faster, and you take it only once in memory. It's not that every process has its copy. So slightly faster and way less memory.
Okay, thank you very much.
Yeah, first of all, congrats on the amazing work that you have done contributing to the community and open source. And my question is not technical, it's more like, do you have any advice for new people that want to contribute to open source? How do you make or break that barrier for a startup, a newbie that wants to contribute?
Yes. Yes, so I have 2 ideas, and none of them are an answer, but they may help building the answer somehow. So tell me after that. One is the story that I said at the beginning. Some random kid goes to the meetup and talks to this big legend, and he just talks to you for 2 hours. Ask, send an email, ping people on Twitter. The community is amazing. Like if you're a bit shy, you don't know where to start, just ask everyone. Just write to Robert Virden. Even he will love it. I didn't say that. If he gets up, his mailbox explodes. I hope it's not my fault, but anyway. The other thing, yeah, at least in the MongooseIM case, that is something that I personally have that impression a lot since I started, where I was a bit more of a junior, at least into Erlang. It was my first Erlang job, and then I started directly into MongooseIM. And seeing the evolution, I think that MongooseIM is a project that it's a lot more developer-friendly by today. Back in the days, it was a legacy project. It was using Dialyzer from the beginning, so not that much legacy. But for example, Xref, we put it into MongooseIM. With Hank, it's not into the CI, but I used it, I did this big pull request killing code, but it's not integrated into CI. Maybe we'll do that sometime in the future. The project is a lot more developer-friendly, so it might also be easier to start. There is all those helper libraries that are used by everyone else. Pick one that tells you something that seems useful and right. People are very helpful.
Adding one thing to that comment. If you are a newcomer and you want to start with an Erlang open source project, go to Slack, say my name, I will mentor you. And we have many other people like me in the education working group at the Erlang Ecosystem Foundation.
Perfect.
So obviously you send a lot of pull requests. Of all the pull requests that you've got merged, which one is your favorite?
Jesus Christ. I mean, the pull request that I send or I receive? The one that I receive is very clear. But that I send, I would say at least outside of my own project, like pull requests that I send to MongooseIM is my job, so let's not count those. I don't know. I was very, very proud of my first pull request to OTP. It's like the dream. It's like there is a tiny 0.001% of me into OTP. Oh god, that's amazing. So there was the base 16, and there was also some cleanup that I did on the TLS code that was a lot more complicated. Base 16 is a super simple algorithm, so you may just make it a little bit faster. But TLS is about TLS. And there was this pull request that I made some time ago, just cleaning code. There was some duplication that I could just remove one and some code reuse and take it outside of a module. And relatively simple, but a very good cleanup that then Ingela told me that it was on their backlog for ages being pushed. But someday we'll clean that part, and then I accidentally did it for them. So I was very proud of that one. It's my code into OTP, it always makes you happy.
That's a great way to